day, everyone. So this morning, we are now down to the last topic, which is the calculus. So I am Angela Rain M. Danyoso, and I am going to present first for the easy round. Then we have Amber Waverly and Sheila May Estareja for the average round, and lastly we have Charina Lopez for the difficult round. So without further ado, let us now start with the first problem on the easy round. Problem number 1. Given a square, how much will the area change if the sides change by 1%? So the first thing that we're going to do is to draw a square with side x. And we can say that A, or the area, is equal to x squared. So step 2, take the derivative of the area with respect to x. So if we take the derivative of that area with respect to x, we get the dA over dx is equal to 2x, where 2x means the derivative of a with respect to x. So to really illustrate a little bit more, we're going to put the dx on the other side. So in other words, we're going to multiply both of the sides by the x, and so we get dA is equal to 2x dx. So dA and dx are what we call differentials, which means that if x changes by a small amount of dx, a will change by some small amount. So in the relationship between that, they will not change by the same amount. So the relationship is undetermined by the 2x, which is the derivative of a with respect to x. So the problem tells us that dx changes by 1%. If x is 1, then dx would be 1% of that. So we can say that dA times x times dx. So where dx is equal to 1% because 1% is 1 over 100 of 100%. Then it's equal to 2 times 1 because 100% of anything is the whole thing. So we have 2 times 1 times 0.01. So 2 times 1 is equals to 2 times 0.01. We have 0.02. Then make it in a percent form, we have 2%. So therefore, if x changes by 1%, there is also a change in its area by 0.02, which is 2%. Let us now go to the next problem. A sphere is constructed with a radius of 1 foot. How much of an error can be made in the radius such that the value will not change any more than that 3%? So step 1, let us draw a sphere with radius of 1 foot. So step 2, let us write the equation for the volume. So the volume is V is equal to 4 over 3 times pi r squared, r cubed. So let us now find the derivative of the volume with respect to r. So dV over dr is equal to 4 over 3 times pi 3 times r squared. So the 3r squared is the derivative of r cubed. Then we have dV is equal or over dr is equal to 4/3 times pi times 3r squared, where the denominator 3 can be cancelled out, and we get dV over dr is equal to 4 times pi r squared. So we are going to transfer dr to the other side. So we get dv is equal to now separating the differential, so dv is a differential, dr is a differential, so we have dv is equal to 4 pi r squared dr, where dr stands for a small change in r and the v stands for a small change in the volume. So excuses for the typographical error everyone. So kanang dv dira kay mo gid na iyahang kuan complete nga form. dv is equal to 4 pi r squared dr. So mo na siya ang sakto gyud nga kuan equation di ara guys. So let's proceed since we're looking for the allowable change in the r as long as dv is not any more than 3%. So that means that, so another typographical error. So that means that dv is less than or equal to 3%. So palihog na lang ta og note guys. dv is less than or equal to 3%. So mo na siya isunod anak. So let's take the limiting value of 3% that will then allow for the maximum area in R. And since we're looking for dr, let's solve this equation for dr. So we could say that dr is, so again another typographical error. So nana siya, dr is equal to dv over 4 pi r squared, where r is 1 foot, dv is the allowable change or the allowable error of 3%. So we have, for step 3, we have the equation dr is equal to dv over 4 pi r squared, where dv is equal to 3% over 4 pi, where r is equal to 1 raised to the power of 2. So we have 3%. So we have 0.03 over 4 pi. So 0.03 over 12.56. So 4 times 3.14, which is the value of pi. Then 0.03 divided by 12.56, we have, so 0.03 divided by 12.56 is equal to 0.00239, which is 0.239 in percent. So therefore, dr is equal to 0.239%. So in the error of r, so the change in r could not be any more than 0.239%. Therefore, the largest error is equal to 0.00239 feet or 0.239%. And if you keep the error in r below that, your error in the volume will not be any more than 3%.